Hey everybody, I thought I'd start going through the solutions to the math assessment quiz first. Please forgive my camera, it's not that great. It has kind of a crappy autofocus. Usually it'll focus on my hand once I start writing, but every now and then it'll jump out of focus like that. And it might take a little bit for it to, there we go, get back into focus. So if that happens, I apologize. I generally keep an eye on it and make sure you can see what the heck I'm writing. So the first question on the math assessment is just to solve this quadratic equation. X squared plus 8x plus 15 equals 0. And there's two ways you can do this. First way is the quadratic formula. This will always work. So the quadratic formula tells us x equals negative b plus minus the square root of b squared minus 4ac. All of that over 2a. So this form requires that the quadratic equation be put in what's called standard form. So this quadratic equation is already in standard form, which is just ax squared plus bx plus c equals 0. So if you have a quadratic equation that's not in standard form, if you're not sure what to use for a, b, and c, your first step should be to put it in standard form, where everything is on one side of the equal sign and there's just 0 on the other side. All right, anyway, let's substitute in. So x equals negative 8 plus or minus the square root of, let's see, 8 squared is 64, minus 4 times a times c. So a is 1, and c is 15. And then all that goes over 2 times 1. So let's work that out a bit. 8 plus or minus the square root of 64 minus 60 over 2, which we can simplify further to be negative 8 plus or minus the square root of 4 over 2, or we could just rewrite this as negative 8 plus or minus 2 over 2. And when we use negative 8 plus 2 over 2, we get the solution x equals negative 5, and we use negative 8 minus, should be x equals negative 3. Negative 8 minus 2 over 2, that's when we get x equals negative 5. So that's how we'd solve, and I see I've run out of room. Okay, there we go. So that's the first way of solving a quadratic formula or quadratic equation. That will always work, unless it'll even work for complex solutions. But we don't use complex solutions, so we won't worry about those for now. The second way to solve this is through factoring. So we can factor x squared plus 8x plus 15 equals 0. And factoring is not something you can always do. You can only do it in certain situations, and generally in physics, we're going to have kind of messy numbers. We won't have nice coefficients on our variables like 1 and 8 all the time. So generally, we won't be able to factor out quadratic equations easily. But we can factor this one. So what factoring means is we're going to break it into two smaller equations that, when multiplied together, give the original equation. So in this case, we can factor x squared plus 8x plus 15 into, let's see, x plus 3 and x plus 5. And we'll set that equal to 0. Now, since this will be equal to 0 if one of these factors is equal to 0, to extract the solutions, we set each factor to 0 and solve for x. So x plus 3 equals 0 gives us x equals -3, and x plus 5 equals 0 gives us x equals -5. So the same solutions that we got before. And just as a check, to check our factoring, we can use FOIL to multiply together. So x plus 3 times x plus 5 equals x squared plus 5x plus 3x plus 15, which is just our original quadratic equation. Okay, so that's number 1. Okay, for number 2, first thing to note is that there's actually a mistake in the equation I wanted you to solve. If you tried to solve this using the quadratic formula, and you probably found that you wound up taking the square root of a negative number. That's my mistake. I originally wrote this problem as x squared plus 4x minus 7 equals 0. So sorry about that. This can't be solved by factoring. So then we have to use the quadratic formula. So the quadratic formula gives us x equals -4 plus or minus the square root of 16 minus 4 times 1 times -7 all over 2 times 1. So we have -4 plus or minus the square root, let's see, 16 minus minus is a plus, 16 plus 28 over 2. And we don't really need to go through that further. Honestly, at this point, what you can just do is just plug into a calculator. And doing so gives us x equals approximately -5.32, and x equals, or approximately equal to 1.32, rounding to the hundredths. So that's what should have happened. What you might have found happened when you did this is if we use x squared plus 4x plus 7 equals 0, then you would have found that you had actually complex answers. What that means is that when we use the quadratic formula, x equals -4 plus or minus the square root of 16 minus 4 times 1 times 7 all over 2 times 1. We wound up with this. 4 plus or minus the square root of -12, which is not something you can usually take the square root of. You can, using complex numbers. What this would come out to would actually be -4 plus or minus 2 square root of 3, which is the square root of 12 part, times I over 2, where I is the imaginary unit and it's the square root of -1. This is not something we're going to deal with in this class. This is well beyond what you need to worry about. So that was my mistake for not checking what I wrote on the quiz and accidentally switching a positive to a negative. And that shows you just what happens when you just accidentally mistranscribe a positive to a negative. Alright, moving on. So number 3 is just a basic right triangle problem. So we have a right triangle of some kind. And let's see, we have side lengths A equals 5 and B equals 6, and we want to find C. So doing this, we would use the Pythagorean theorem. A squared plus B squared equals C squared. In general, we can use that to solve for the third side of any right triangle if we know the other two sides. So let's see. Let's plug in. 5 squared plus 6 squared equals C squared. So 25 plus 36 equals C squared. So 25 plus 36 is actually 63. So c equals whatever the square root of 63 is. This is where your calculator comes in. You should get something very close to 8, but not quite. So the square root of 63, according to my calculator, comes out to be 7.94 if I round to 2 decimal places. Make that approximate. Okay, and then the other situation is if you have, let's see, a equals 5, c equals 13. So again, we can use the Pythagorean theorem here. This time we'll solve for b. So b equals the square root of c squared minus a squared. So let's see, c is 13, so 13 squared is 169. A is 5, so a squared is 25. 169 minus 25 is 144. In this case, this is actually a perfect square. So b equals 12. 12 squared is 144. So this 5, 12, 13 triangle is an example of what's called a Pythagorean triple. Probably the one you're probably most familiar with is also a 3, 4, 5 right triangle, because 3 squared plus 4 squared equals 5 squared. But 5, 12, 13 is another Pythagorean triple. All right, for number 4, I see I actually used the 3, 4, 5 right triangle. So let's see, here's our right triangle. We have side lengths of a equals 3, b equals 4, and c equals 5. And now I want to find, let's see, let's call that angle B, and this is the right angle is angle C. Okay. So we want to find the sine of angle A. And remember our mnemonic for right triangles, SOHCAHTOA. You know that sine A is the opposite side of the angle over the hypotenuse of the triangle. In this case, the opposite side is 3, and the hypotenuse is 5. So sine A equals 3/5 or 0.6. So we didn't really need to round to the nearest hundredth for that. Now we want to find A. We want to find A in degrees. So to do that, we'll use what's called the inverse sine, or more properly, the arc sine. Written like that, which is the inverse of the sine function. It's usually on your calculator as sine to the -1. That doesn't mean 1 over sine, that means inverse sine. It's kind of a bad notation that somehow has gotten stuck in the math world. So we're going to have to deal with it. So A is equal to the inverse sine of 0.6. Basically, we take the sine of an angle and we calculate what the angle is using the arcsine function. So using the arcsine function on my calculator, I find that the arcsine of 0.6 gives us an angle of approximately 36.87 degrees. Okay, so number 5 is pretty straightforward. I just want you to put this equation, 8x minus 2x squared equals 3x squared plus 6. I want you to put it in standard form. Standard form means I just want it to be in the form ax squared plus bx plus c equals 0, in preparation for using the quadratic formula. So this should be pretty easy. We just add and subtract as necessary to move stuff onto one side of the equals sign. So if we move that 3 over, that 3x squared over, we should get, let's see, minus 5x squared. 8x by itself is fine. And then we need to move that 6 over by subtracting as well. So here's our quadratic equation in standard form. Pretty simple. All right, I'm going to do 6, 7, and 8 all at once because they're very simple and all basically are the same type of problem. I want to find the sine of 77.3 degrees. I want to find the cosine of 60 degrees. And I want to find the tangent of 45 degrees. And we're going to round these to 4 decimal places. 4 decimal places is kind of a standard rounding for sine functions. In terms of significant figures, when you're using sig figs, as long as you include the correct number of significant figures in your angle that you're taking the sine or the cosine or the tangent of, you can just assume perfect accuracy in the case of your sine function. So you can treat that as a constant, basically, like 2 or pi or something like that. Because we don't measure the sine of an angle. That's just something we calculate. Okay, so let's see. The sine of 77.3 degrees, according to my calculator, is approximately 0.9755. The cosine of 60 degrees, I can tell you from memory actually, is going to be 0.5. The cosine of 60 is just 1/2. And then finally, the tangent of 45 degrees is going to be, if I remember right, 1. So there's certain values of the sine, cosine, and tangent functions that actually have, easily memorizable values. They're not just a random series of digits. And the usual ones are 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So I can write those down. I'll just take a minute to write those down for you to keep in mind. So let's see. How am I going to do this? I'll do this as a table. So here's sine. Here's 0 degrees. Here's 30 degrees. Here's 45 degrees. Here's 60 degrees. And finally, 90 degrees. Okay, so the sine of 0 is just 0. The sine of 30 is 1/2. The sine of 45 degrees is actually the square root of 2 over 2. And the sine of 60 degrees is the square root of 3 over 2. And finally, the sine of 90 is 1. As it turns out, cosine is these values but reversed. So the cosine of 0 is 1. The cosine of 30 is root 3 over 2. The cosine is equal to the sine of 45 degrees, root 2 over 2. And then finally, the cos of 60 is going to be 1/2, and the cosine of 90 is 0. Tangent works a little bit differently than sine and cosine. Oops, sorry. Okay, so the tangent of 0 is 0. The tangent of 30 is actually the square root of 3 over 3. The tangent of 45, as we saw, is 1. The tangent of 60 is just the square root of 3. And then the tangent of 90 is actually undefined. Technically, I think you can call it infinity, but we usually just call it undefined. So you can't take the tangent of 90 degrees. And finally, if you're not getting these values for sine 77.3, cosine 60, and tan 45 on your calculator, check to make sure that your calculator is in degree mode. Depending on the type of calculator, you might have 2 or 3 types of angle measures. The two that we'll actually use in this class are degrees, which is usually deg, radians, which will come up when we do rotational motion, usually as rad, and then we have a third one called grads, which is kind of an old-timey engineering unit that's not really used at all in physics. So usually on a calculator there's a DRG or some sort of button. And on your calculator there should be some indication of whether or not you're in grads, radians, or degrees. So I think on TI-83s and 84s there isn't, but you should be able to change that by going into mode. My calculator is TI-89, and I can change that by going into mode and changing my angle measure to degrees. You can't really see that because it's out of focus in a tiny screen. There we go. So I'm currently in degree form. I can also change that to radian, but I'm not going to. On scientific calculators, usually it's a DRG button. On graphing calculators, there's usually some sort of menu option you can use. I'm not terribly familiar with calculators other than TI-83s, TI-84s, and TI-89s, but there's probably a fairly simple way to make sure that you're in degree mode. You can probably search the manual of your particular calculator model on Google. Finally, I'll end by going through the geometry problems I have on here all together, kind of like I did with the trig problems. So let's see, 9, 10, and 11 are all just basic geometry. So number 9, we want to find the area of a rectangle with side lengths 7 and 12. Well, the area of a rectangle is just its length times its width, so that'll just be 7 times 12, which is 84. For 10, we want to find the area of a circle with a radius of 5. That we're going to have to round. So remember, the area of a circle is pi r squared. So it'll be pi times 5 squared, so 25 pi. This is an exact way of representing it, but in physics a lot, we're usually going to actually calculate a number, not just 25 times pi. So rounding it to the nearest hundredth, we should get that the area of this circle is going to be 78.54 square units, whatever unit 5 is. And then finally, for number 11, we want to find the area of a triangle with base of 4 and a height of 9. And remember that the area of a triangle is just 1/2 BH. So we have 1/2 times 9 times 4. 9 times 4 is 36, times 1/2 is 18. So we don't need to round here. Let me circle those up so we can box those up so we can see them. So that's it for the math assessment quiz. So let's make sure you can get a good look at those solutions. I think it was pretty straightforward, except for the error I made on the transcription error I made on problem 2. I apologize for that. I will attempt to be more careful with my quizzes in the future. If you have any stuff you're still unclear about on the math part of this course, please don't hesitate to email me. Some of the stuff can be a little tricky, especially with vectors. If you're not familiar with vectors or if you haven't used them in a while, read through my lecture notes on vectors and check the textbook as well. If you're still struggling, there's a lot of good demonstration videos on YouTube and also Khan Academy. So that's it for my review of the math assessment quiz.